Buonasera. Perfetto. Okay. So should I take it from the top? Ci siamo? Ok, vabbè. Perfetto. Ditemi quando partire allora.
Sui minigiochi in attesa, una palla, qualcosa.
Filippo di Fantix.
Vai e temporeggia finché riesci a far funzionare il video.
Guardate tutti da quella parte. So here we are. Hi everyone, welcome to PyData's January edition. For newcomers, PyData is a network of communities of developers and users of open source data tools. It's a program run by NumFocus, which is a US-based nonprofit that promotes open research and data tools. Be nice. And stay in touch. We aim to host monthly meetups, more or less every third week of the month on Wednesdays. These are our next events. They will be available on Meetup soon, so keep an eye out. We collaborate with a lot of companies around Milan that always very gracefully host us. Today's sponsor is Talentware, to which I will leave the floor for 1 minute.
Okay, anyway. Good evening all. First of all, welcome to our office. So
Before jumping into more interesting stuff, we have today Clearbox, then we talk about also what we do here at Talentware, but I would like just to spend a couple of minutes to tell you a little bit what we do here and what we're trying to solve in Talentware. Since luckily I'm not talking to HR now, maybe I can give you a little bit of an introduction of what it means creating a talent management software to support and help companies to adopt a skill-based approach to their organization. So first of all, what does it mean skill-based? Basically, we want to enable companies to have a transition from a role-based approach to a skill-based. And it means that people are not just recognized as job titles or job roles within the company, but depending on the activity they do and on the skills that they have. And in order to achieve this level of precision, we're able, of course, to identify and map technical skills, managerial skills, and behavioral skills of each employee within the company. This is our entry point, so we enable them through our technology to identify the skills of each employee, which then power our solution and our platform to really, to really act as a strategic tool for the company, so for the HR and for the managers to put the right people into the right place at the right time. At the same time, Talentware acts as a co-pilot for the employees to guide them throughout their career journey and development journey within the company. So in our modules, skill intelligence, planning and mobility, development and growth review, we really want to cover the whole talent management life cycle to guide the employees in their growth within the company. So for instance, if you ever ask yourself, okay, I'm a data scientist now, and what I have to do in order to achieve or to become the tech lead in my division, or any other questions that usually don't find any answer within the company, then this is the right tool for you. So if you ever ask this question yourself, feel free to make us a referral in your company. Or again, if you don't find any career opportunities or growth opportunities within the company, then I mean we're growing pretty fast and the team is expanding. But yeah, this was just to give you a brief introduction of what we do. Then Raffaele will deep dive a little bit on the technology that we are adopting and the journey that we are doing also in our data department. But yeah, for now, leave the stage to our guest, to Clearbox. And if you have any questions, feel free to stop me also during the aperitivo. Thank you.
Aspetta un secondo ancora, devo andare indietro alla...
Luca, tu mi senti?
Ok, perfetto. Vai.
Prova.
Okay, so one final thanks to Python Italia and to Division Lab for supporting us and providing us with the recording equipment. And last, well, the slide's missing, but we are going, Talentware is very kindly offering us aperitivo. We are still going to go for dinner afterwards, so can I have a show of hands of the people that are interested in having dinner after the meetup? Okay. Can someone count? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay, let's say about 10. Okay, so I'll now leave the floor to our guests.
Hi everybody, I'm really happy to be here. I always enjoy participating to this kind of events. We are based in Turin and we are quite active with Python Torino, Database Torino, Python Biella, if you know it. So it's always nice to have this kind of exchanges. And today, the idea is to give you, to tell you a story about a project that we've been working on during the last year. As Clearbox, we are a company working on the synthetic data space. So in the last, we were born 5 years ago at the University Incubator of Polytechnic of Turin. And we have been working on the topic of synthetic data. We do a lot of commercial projects, but we also do a lot of research because it's a topic that constantly needs to be studied. And today I'm going to tell you about a library that will developed within a European project, which is a library to assess and validate synthetic data. I'm with my colleague Dario today. I will just give you a brief introduction about the library, about the concept of synthetic data, and Dario will walk you through the library because he was the main developer. We are at PyData, so probably it's not really smart to tell you what synthetic data is. You might be all aware about the notion, but it's fictitious data, so data that is created artificially with the scope, with the aim of resembling as much as possible a source data set. So we create data that doesn't exist. It's not collected from real life collections or real life samples, but it's created with the aim of resulting realistic. And that means that can be used, of course, to train AI models. Machine learning models and AI models are thirsty of data. Sometimes we have to deal with problems such as data scarcity, data quality. The data set can be very imbalanced. The data can have a lot of information gaps. And the idea is that we could, if we were able to generate realistic data, we could use this data to fix some of these problems affecting our data sets or bootstrap projects if we don't have enough data. And another reason we might want to use synthetic data, if you worked in the data space, you might be aware of the pain of working with personal data. Of course, in Europe, we have a lot of rules, which make sense, of course, but rules that tend to slow down innovation in terms of what we cannot do with personal data. And the idea is that if we have a data set, a database containing a synthetic population, this database doesn't fall under the GDPR umbrella anymore. And then we could do a lot more things. We could do data sharing. We could use this data for doing software testing. It could unlock a lot of stuff that nowadays might be very slow or impossible to do. And that would be a dream. Of course, we would be very happy to have this kind of data, so anonymous but useful. There are a lot of ways to generate this kind of data. One approach is when we don't have data at all. We could use some approaches like simulations or agent-based modeling, which requires some expert sitting down and doing a lot of data modeling. An expert that, for example, they might need to define what a financial transaction is and create an agent and put this agent in an agent-based model and construct a data set containing financial transactions. This data is, of course, completely anonymous, and it's built based on the expertise of a person. Or if we want to use data for computer vision, we could use a gaming engine to create an environment and use this data to train models for computer vision. Today, we're not going to talk about these approaches, but we're going to focus on another approach, which is the generative approach. You might have heard, of course, about generative models. The idea is that we can fit a model on an existing data set. Fitting a model means that this model will eventually learn what are the probability distributions characterizing our data, and this knowledge might allow us to sample new data that was not existing before. There are many ways to train generative models. They've been every month there's a new idea, a new approach. They're all based on the notion that we can fit a model on an existing data set. We can make it so that we can sample new complex data points based on a simple sampling distribution. For example, if you use a variational encoder, you sample from a normal distribution to obtain complex distributions, but they're based on the concept of using some source data. When we have this kind of models, they're basically machine learning models, and they're affected by the same issues that affect any machine learning model. So when we want to generate data using these kind of models, we have to be sure that we are doing things properly. And what does it mean? It means that, first of all, we want to have data which is faithful of the original distribution. So we need to have an assurance that all the characteristics in terms of probability distributions are preserved and respect. But we want to make sure that this data is actually new, that there's a degree of novelty in our data. Why am I saying that? Is that a lot of generative models have an issue with learning too much about the original data. For example, you might have heard about that with diffusion models, some researchers were able to extract the training data from the diffusion model itself. So they were able to sample what looked like new data points, but there were actually data points that were existing in the training data set. And that's, from a privacy point of view, is terrible, because it means that if we assume that we can use this synthetic degenerative model to generate new data, it means that the generative model is generating personal data, and that's something that it's quite catastrophic. On the other hand, if you use this data to train a machine learning model, it means that we are not providing the model with new information. We are just copy-pasting information that was already existing. And this kind of problems affect several models. For example, if you ever work with generative adversarial networks, you might have heard of mod collapse, when the generator learns to generate images that are confusing the discriminator, but are actually sampling from a very limited distribution. So they're sampling images that are very similar to each other, because the loss function eventually converges to this trade-off. And this, of course, is something that we want to avoid. So the objective of this work we did last year was to create a library called SURE to evaluate and assess synthetic datasets. And I will give the floor to Dario, who was the brain behind this library.
Thank you, Luca. Very cool job. Okay, thank you very much for the introduction. Yeah, we'll now see our new release, SURE, an open source library, Python library, for the assessment of utility and privacy in synthetic data. We'll see how, as Lucas mentioned, synthetic data can be a valuable privacy-enhancing technology, so used to anonymize maybe a sensitive data set that contains sensitive information, but anonymization alone may not be sufficient, and thus it is extremely important to assess quantitatively what are the privacy level of our data set, without forgetting, of course, about the usefulness of data, the informative content. So, okay, sorry. We designed SURE with a few requirements in mind. It is compatible with tabular data and time series. It's able to process large-scale data sets. It is based on polars and on Cython, which is an extension of Python that gives the code C, C++ performance in terms of speed. And also we wanted to be accessible to non-technical professionals to some extent. So the library eventually produces a report in the form of a visual digest that summarizes all the information and metrics computed before, accessible also to maybe data protection officers or a legal professional, in the hope that this tool can support decision-making when it comes to disclosing a sensitive data set. These are the modules that make up the library. We see on the right that the inputs to the library are, of course, the synthetic dataset, the training dataset used to train the synthetic generator, and a holdout dataset, so a portion of the original dataset that was not used to train the generator that produced the synthetic dataset. After a preprocessing stage, where the datasets are prepared for the following stages, the main modules take over, which can be divided into two groups. The ones devoted to assessing the utility of the dataset and the one dedicated to evaluating the privacy. Eventually, as I mentioned, utility and privacy report is produced. We'll see later on more into detail. Let's start talking about the metrics, in particular the utility metrics that are integrated into the library. The first module is the statistical similarity module. It's basically devoted to computing general statistical features on both the synthetic and the original dataset. So it provides, let's say, a high-level description of the statistical properties of the two data distributions. And it allows us to verify that the synthetic dataset reflects statistically mirrors the original data. The second module is probably more interesting. It's the machine learning utility module. It basically trains a pool of models, of machine learning models, both on the synthetic dataset and on the original dataset, and the results are evaluated. So let's describe this one a little bit more into detail. The machine learning utility module, as I said, can run two different machine learning tasks: classification and/or regression. Training a group of machine learning models that the user of the library can select, both on the synthetic data and on the original data. And the trained models are then evaluated on an holdout portion of the original dataset. The metrics computed at the end can be displayed in a table like the one you see on the right. And what's interesting here, you have a list of all the models tested and the metrics on the columns. But what's interesting is not the metrics values themselves, but comparing the value for one metric on the real and on the synthetic dataset. And this value, we would like it to be very similar, of course, because if it's different, it means that the machine learning model behaved and learned differently between the synthetic and the real dataset. So it is a way to assess that our synthetic dataset contains the same information as the original one, and it's a way to assess its machine learning utility. Yeah, we can visualize it in another way. This is just the difference between, for the same metric between the synthetic and the original dataset, and we want this number to be very low, as I said. Let's move on to the privacy metrics that are integrated into SURE. The first one is the distance to closest record. This is a metric based on a distant metric that allows us to identify vulnerable records within the synthetic dataset. Vulnerable records are records that are too similar, too close to some records of the original dataset, and may be subject to re-identification in case of a privacy attack. Privacy attacks such as the membership inference attack. So in SURE, we have the possibility to evaluate the membership inference risk, which gives us an idea of what would be the outcome of a privacy attack on our synthetic data. Let's start describing the distance to closest record. As I said, it's based on a distance metric, which can be computed between two records of the two datasets. So we can compute the distance between a record belonging to the original dataset and one belonging to the synthetic dataset. We have chosen a modified version of the Gower's distance because it takes into consideration both categorical and numerical features, giving us a good idea of, considering all the kind of features. And this distance can be computed for instance, for the first synthetic record, relatively to all the records of the original dataset. So we will have a list of distances, and between these, we select the shortest. So the shortest of these distances will be the distance to the closest record for the first synthetic record, relatively to the original dataset. Now, we can do this between the synthetic and the training dataset. I've mentioned it before. The training dataset is the one used to generate the synthetic dataset. And we can compute the distances also between the synthetic records and the holdout dataset. So we would end up with two lists of distances, one relative to the synthetic to training and one to the synthetic to holdout records. And these distances can be displayed with the classical distribution curve that you see there. So on the x-axis, we would have the distance values, and on the y-axis, the counts. Now, a more interesting way to visualize these results is by displaying the two distributions on the same graph. We can make some considerations on these distributions. For instance, in this case, the two distributions are almost perfectly overlapped. It means that the same amount of synthetic records are closer to the training records, and the same is true for the distances from the synthetic to holdout record. Let me explain it a little bit better. We can put this into numbers, and in particular, that percentage there, as it's written, is the share of synthetic records that are closer to a training record rather than to a holdout record. So half of the records of the synthetic dataset are closer to the training set, and the other half is close to the holdout set. So this number would be close to 50%. And that's something that we are looking for in our data, to this number for this number to be close to 50%. That's because it means that our generative model has been able to generalize properly, while if we were on this other situation, the two distributions are clearly very different. And in particular, the synthetic to training distances are way smaller than the other ones. It means that there are more synthetic records that are very close to records of the training set. So this percentage would be way higher than, greater than 50%. And this is a symptom of probably overfitting of the generative model on the training dataset. And it's something we really must evaluate to be sure that there are no records in the synthetic dataset that are too similar to records of training set, because those records will be very vulnerable in case of privacy attack. And let's describe now an example of privacy attack. So I've mentioned before that anonymization is not sufficient to be 100% sure that our dataset is privacy preserving. In fact, it can be the case of membership inference attacks, which consist in establishing whether a known record of which the attacker knows some information belongs or not to the original dataset. So this can be done, of course, with the by accessing the synthetic dataset, but also having other informations about some real record, so belonging to the original dataset. Informations that are defined like indirect identifiers, so they are not unlike direct identifiers, which are like name, surname, or ID number that directly identify a person. Indirect identifiers are information like height, gender, native country, etc. So information that alone do not identify an individual, but if in combination with others can single out an individual for a group, from a group. Let's make an example to make it clear. A simple example. So let's say that I know that my neighbor is coming and going from the hospital. And of course, I know a lot of information about him. He's my neighbor. I know his height, his gender, where he's from. I know that he lives next to me, so I know his city of residence. I know some of his habits. I know that he smokes, for instance. And let's say that I put my hands on a dataset released by an hospital, a dataset on patients with cancer, for instance. And the hospital made sure that this dataset was anonymous, so they removed all direct identifiers. There are no names, no IDs, etc. But I noticed that in this anonymized dataset, there's an individual that is very similar to my neighbor. It has the same, same height, same gender, many other informations. And I can say with a certain confidence that my neighbor was part of the dataset that the hospital used to generate the synthetic dataset that they shared. Now, this is a very simple example, but it's just to convey the idea. Usually, way more complex techniques are used, like machine learning models. And to make another example, let's take a real case that happened in 2006, when Netflix decided to public a dataset, anonymized dataset, on users about reviews of movies and ratings of movies. They did that in the occasion of a prize. They would give a prize to whoever improved their recommendation system, their movie recommendation system. So this was their aim. And they considered the dataset to be fully anonymous. But some researchers came out with a few papers proving that they could break the anonymity of this dataset, performing membership inference. And in particular, they used as prior knowledge some public information available online, like on Amazon reviews or on IMDb, which is a very famous website for reviewing movies. they managed to link the public accounts to the Netflix users, maybe sometimes comparing a review of a movie which had the same exact text, or comparing the list of movies reviewed by a user which were very similar, etc. So in many ways it was possible. And what was the outcome of this? They, in some case, the movies reviewed on Netflix, for instance, were different. There were other movies reviews by the user, and they could infer other very private information like political or religious or even sexual preferences of this user, information that were, of course, very sensitive, and most of the users would like to remain private. They managed to do so by breaking the anonymity of the Netflix dataset with membership inference. So this is why we should take an eye on this kind of privacy attacks that are possible, even though our dataset is anonymous. And this is why we have a module dedicated to simulating membership inference attack in the Sure library. It is possible to initialize the attacker with some prior knowledge about some records, and running a machine learning model, the simulation would outcome with a probability of confidence saying 80% this record belongs to the original dataset from which the synthetic dataset is derived. So this is why it's important to take it into consideration. Finally, as I mentioned, the last module is about producing a visual digest, a report that graphically summarizes the metrics that I've just described. This report can be shared with maybe within the same organization to support decision-making about disclosing or not a given synthetic dataset, and making sure that it adheres to privacy constraints, and still having a, let's say, maintaining the usefulness of the original dataset. Okay, so this is the link to the GitHub page of the Sure library. You are more than welcome to try it out. And I take this occasion to also mention that we have recently released our library, the synthetic kit, which is for synthetic data generation. So it's they both are completely open source. You can try them out and let us know what you think. So if you pass by GitHub, please, it's very appreciated to drop a star to support open source projects like this. So thank you very much for the attention, and I'm finished. If you have any questions, of course. Yeah.
What's the license for the library?
It's Apache 2.0, I believe. Yes.
Second. Thank you. Do you also cover key anonymity in the metrics in the report?
We plan to expand the library with different functionalities like key anonymity and others. Also, we have a project to extend it to text and images, but they're all in to-dos.
Thank you.
Any other question?
Okay, then
thank you very
much.
You very much.
Okay, so thank you to Luca and Dario. Okay, so now it's Raffaele's turn. So other turn. Please. Thank you. There you go.
Oh, sì. Prova. Okay. Hello, everybody. Thanks for coming. Okay. Test. Okay. Thank you, everybody, again. Thanks for coming. This is a very important day for us because it's my first Padeta. It's the first tech event in Talentuar history. And it's also the first year of the Talentuar data department. So I wanted to tell you how it's gone. When I've been hired by Talentuar, so embrace the challenge of building, along with the founders, the data department, I had an objective. I wanted to build a mature data department from the very beginning. So I wanted to make treasure my experiences. But what? This is wrong. Okay. Okay. Okay, better. So what is maturity? This is an error that I didn't add in the past, so it's the first one. So what is maturity? Maturity is the concept of maturity reflects the capacity to act effectively based on comprehensive experiential insights. So be mature means directly mapped with experience, that is the time doing things, spent doing things. So when reading this definition, a question raised to my mind: is an Italian AI environment mature? So navigating navigating the web, I found these different portraits of Italy, very different. The first one is related to traditional software development, and the numbers are pretty good. We see that the numbers are good and are perfectly in average with the European stats. Instead, when we look for AI environment, the numbers are different. There are many motivations behind this. We will not discuss all of them, but the thing is that we don't have today a lot of, very few actually, mature companies. For mature companies, I mean with full technological, organizational, and managerial maturity adoption, AI solution adoption. So one of these motivations is that people usually treat AI development and AI software like traditional software development. This is wrong at all, because there are, yes, some intersection between the two development, but AI projects have their own specificity that need to be considered. So what differentiate actually an AI project and traditional software project? There are also, in this case, there are many points, but I wanted to highlight 4 of them. The first is, of course, the data. In traditional software, data are important, but not like in AI software. You can't even start an AI project without data. Then AI projects have an experimental nature. So you need to iterate, to try, to explore before finding the correct methodology. Instead, in traditional software, in this case, is more straightforward. The AI software has a probabilistic nature, so you have to deal with probabilities. You have to deal with non-determinism, and this is a very big deal. Then AI project never ends. When you think that you have handed, you have delivered, you have trained your model, you have to schedule at the very beginning a maintenance effort to even keep only the quality that you have delivered at the end of the project. So these are 4 main points, and in Talentuar, I wanted to consider all of them from the very beginning, and so the Talentuar data department has born with the objective of keeping in mind this point, and also with the mission to create a data-centric organization where everyone in the company, everyone involved in an AI project knows these things. So this has gone pretty well, I think. We have built many AI assets in this year that are delivered to our client, exposed to client, and they are used, and we are still improving. And to do this, we founded our department on 3 main pillars. These pillars are a cultural pillars, that is stakeholder evangelization, an operational one, based on an AI-specific framework that we designed, and a communication pillar. that is based on clear and frequent information sharing. But how these pillars actually practically impact the day-by-day work? So let's start from stakeholder evangelization. This is not just information sharing, but it's really a cultural shift. So any member of the company need to internalize the key points that I show you below. So we focus on centrality of data, so emphasizing with any person in the company the garbage in, garbage out concept. So this ensure that stakeholders understand that if we have low quality data, we cannot provide a good quality output. And also, second, but very important, this allowed us to support, to make easier for the stakeholders to support the creation of high quality data asset, because they have access to different abstraction level of information. So they can facilitate the technical work to create a high quality data asset. Then we focus on the fact to share that some tasks produce knowledge in AI project, do not produce product. What does it mean? This means that when we do some development cycle without delivering anything, doesn't mean that we are not working. We are just creating knowledge to find the correct path to succeed in the AI project. So this is the intrinsic experimentation nature of the AI model, and it's a very important thing to share and to share with the stakeholder. Finally, the AI projects are strategic projects. There is almost no AI project that is not strategic. So what does it mean? That the timeline are longer, and the stakeholder need to do an extra effort to keep the trust through the process. Because when the project has a longer timeline and you don't see the end, actually, you see the end after months, you have to do an extra effort to say, okay, they are working and they will reach eventually the result. So how we do this? We do dedicated workshops. So we dedicate time for sharing this information with all the stakeholders, and for Q&A and doing deep dive on these topics. Then we reinforce the key concept in every meeting, also leveraging informal moments, because that moments like dinner, team building activities, coffee breaks are the moments in which the culture is created, and we want to create culture, not sharing information. When we have a stakeholder evangelize, or the project, the process is started, we have a fertile soil on which to build AI projects. So then it's the moment to get the hands dirty and working. We designed this operational framework that has a lot of intersection with traditional software. We can see business requirement definition, for example, that is highly important also in traditional software, of course, but the impact is different, I think, because in AI development, if the requirements change in the middle of the project, you have the business requirement directly mapped with the methodology that you have to use. So this can disproportionately impact the project, because you should change maybe the methodology and start from the very beginning. This is a big loss of time and money. Then we have to share in the start phase the success metric, a metric that is based on your use case, so that quantify the quality perceived by the user, the end user. So it's not just a fancy technical model training loss that we need to optimize, but something that quantify the satisfaction that will have the end user. This is very important to have a stop on your project, so avoiding over-optimization, and also because you don't want to find yourself at the end of the project having optimized your fancy model loss and then find a user unsatisfied. Then we have to provide a comprehensive cost estimation. This is also an intersection with traditional software, of course, but in AI is more difficult because we have many technologies, many different technologies, many different providers. Each provider has its own model cost or pricing model. So can be very, very hard to provide a good estimation, but we have to do this, and we have to also take into account any phase of the AI project or the AI development. We have to take into account experimentation, we have to take into account serving, maintenance, because they are costs, and we want to have a project, a final result that is economically sustainable, of course. Finally, least but very important, is the expectation. We have to manage the expectation. Never oversell your project, the capability of your model, because all the other departments base their work on your projection, or what you say. My model will do this. So that information will be also exposed externally. So if you provide overselling, this can be a big problem for the whole company. After the setup phase, we have the implementation phase. Now we can work, actually. We have 3 main points here. The first is to set medium and long-term objectives, to have a focus on the bigger picture and not avoiding to get lost in subtasks. Then we have an adaptive development cycle. So we don't have 1 week sprint fixed, but we adapt the length of the sprint based on the topology of the task. So if we have more experimental tasks, or we have some technological scouting, we have complex tasks, and we want to try a different solution, we adapt the length of the sprint based on this typology of task. This is important also for 2 reasons, because we are able to keep the quality high, but we develop trust because we respect commitment in this way. And this is critical for a longer project, as I said. Then we deliver incremental products, data products. Every time we have some added value, we deliver and make it tangible for the end user. So we deploy new pipeline step, we deploy new model. Also, if we have a small improvement, because in long-term project, you have to show it anytime you have. Then the final pillar is the clear and frequent information sharing. This is important through the implementation phase, of course, to share the state of the work. We have 3 key points here also. The first is the shared glossary. We always have a shared glossary for all the important words related to the project. This seems trivial, but I'm sure that any one of you have found himself in a situation that where some guys call the same feature in a different way, and this can create miscommunication. Then we have regular meetings, like for the sprint planning, the daily stand-ups, and feedback meetings, and for different level of abstraction. So in any meeting are involved the same level of stakeholders, and we provide a certain granularity level of information. So there is not the situation in which there are people that do not understand some technicalities or some granular information. Finally, to expose the state of work, we use a modified version of the Sign-Effing mental model. It is a decision-making tool that looks like this. This is a matrix, actually, based on 4 dimensions. Each dimension is a dimension that anyone in the company can understand. So business value that a task will create, the output definition, the tech solution complexity, and the delay estimation. So in the first quadrant, we have clear tasks. So task with all these dimensions, clear, very straightforward. The second one is for complicated task. So task with a higher complexity definition, the solution, and so in which we have maybe to experiment some new technology, and the delay estimation is a bit fuzzy in some case. Then the third is for experimental task, so where the business value will be known just after the end of the experimentation. And the final is for chaotic task, when some request, for example, comes from the business, from the sales, and tasks are not well defined. So we need the objective of that point, the quadrant, is to organize meetings, speak with people, and move the task in one of the other one, so it can be worked. So just some closing thoughts. This is how we set up our department, and I hope that the message is passed that AI software is not like traditional software. There are some intersections, but we do not have to bypass the AI specificity. And I wanted to share also this thought that I did. Data science and AI are young disciplines, so we are pioneers in this. And we have to be critical about the way we work, the process that we have, our data department, and in our companies, because we can make AI environment more mature. Thank you. This is feedback. We will be glad if you answer these feedback. So just use that for the link, and thank you.
Okay. So, okay. Any questions? There you go.
Thank you. Thank you for the presentation. I got interested in the shared glossary. And I would like to know, how is it built? Is it a text file? Is it a doc? Is it physically a glossary?
Yeah. For every project, it depends from the size of the project, of course. When we have big and longer project, we write on notes. Actually, it's a file, text file. All the words that are that get confused during the practical session, the meeting. So the glossary it's built on the run. So when we see, look, you call this feature somehow, I call this feature another way. Let's choose a name, write it down. So when it's very simple, but it's just a way to start to do things and avoid miscommunication.
Can I add 2 other quick questions about this, even if it's a small part? First is, have you ever faced any situation in which the writing of the glossary is some way intended as a time waste and so avoided? And the second one is, who is in charge of writing it?
Okay, no, because it's very fast operation. Actually, it's as I said, it's not like okay, take an hour and write all the words that came to your mind. It's like running things. You do this, okay, let's write it down. So word by word. And the second was
who is in charge of writing it?
There is no owner. Actually, it's a shared document, so you can anyone say let's write it down. This is possible also because we are 10, I think. I didn't think about the scale these things. Of course, it's early, but yeah, that's how.
Thank you very much.
Other questions? Okay.
I have a question. So basically, you said that AI software development, let's say, it's a little bit different from the traditional one. So there is not the risk to create another silo for AI. Let's say typically there is a backend team, a front-end team, always arguing, always fighting. There's not there is the third ball in the development cycle too.
Okay, yeah, I got you. Thank you for the question. I think that are 2 different topics. What I want to share is more, look, there are differences. We cannot bypass them. They cannot be overlooked. So for an efficiency matters. What do you mean for silos? I think that I found it, for example, in companies where I worked, where these differences weren't taken into account. The point there is the communication and the culture, I think. because when you are culturally, your company, it's culturally open to embrace the differences. It seems philosophical, but it's not actually. And you think about the complexity of the work and the difference of the work of each team, you are able to do the best in your department to facilitate the work of the other department, for example, the other software development teams. So what I think is that being aware of the differences and operationalize the differences in a different way. It's not creating silos, but it's making more efficiently the work. And the silos have to be broken, the bridge have to be created by the culture. So you have to know what the other department works and what is their part in the big project. And everything you do need to be, when you plan to do something in your department, you need to take into account the impact on the other teams and the interaction. So it's more matter of communication, culture, of doing things not for your department in a silo, but for the whole company.
So I have another question about the concept of sharing knowledge with the stakeholder. So, perfect. Okay, so because I like the part that you say that sometimes we don't do stuff, we make something to improve the knowledge, and we have to ask trust from our stakeholder that we are doing something useful, but for a long period maybe we don't share with them nothing. So the question is how you gain this trust with your stakeholder, and if at the end of the process you show some value about your project and how you communicate or how you measure the value that you make with the project.
Yeah, thanks for the question. There are 2 points. The first is that this is the stakeholder evangelization, so it's the base of every project. This is setting up the culture. So for this I said, this is not information sharing, it's cultural thing. You transmitting these key points, it's like you are making them learn the words, the basic words of the AI world. And I see this in practice in Talentor, for example, where I was the first technical machine learning, and I start to share with my founders and also the other team members this concept that for us seems to be like super easy, super normal, but the fact that something is not deterministic, that you have to do experimentation, that you don't, it's not like using just the first library that you find and you go straight forward. That was difficult. So the first part is transmitting this information and make them aware that there are differences. So when your stakeholders, team leaders, managers, all these stakeholders understand that there are differences. Between these differences, there is also the fact that for a certain time of period, you will not deliver any product, but you are experimenting. When you communicate that you are experimenting, you are producing knowledge, it's different. You start from a different level. You are not a level ground. You are level 1, level 2, depending on the mind openness of your stakeholders. So just first thing is extend the culture, and you already start from some floor. Then also when you are producing knowledge, the fact is the cultural shift is not only delivering product, is delivering something. Delivering knowledge is delivering something. So then when you do experimentation and produce knowledge, when you train a model to fine-tune parameters, you find some glitch in the dataset, that is some knowledge, some output. So if the people with which you are speaking are on the same page and knows what does it mean producing knowledge, when you speak about, well, look, I found this glitch in the dataset, we are one step forward to the solution, that is something, and it's perceived as an achievement, as a work. So I think that is, so the stakeholder evangelization is important to create the ground, the level ground, so the level 1. And then when you are customized, the people with which you speak, that you are delivering something, also when in experimentation, the perception is that you are working actually. So that's my experience. I think that there are also other opinions in the room, but that's how we.
Other questions? One, two. See? Okay. So, thanks everyone for coming.
Thank you. Who does not have the ticket for the aperitivo, comes to me.
One missing.